Good morning, everyone. Uh, Today I'll be taking you to the introduction of unit number one. Uh, I think Shinde sir, had covered some part, but I would like to start it from the beginning. So I'll start with unit number one of your CAD CAM automation. Unit number one consists of introduction to CAD systems, and then the second important point is transformations. So we'll start with the introduction of CAD, and then subsequent sessions we'll discuss the transformations. So basically, CAD is computer-aided design. Most of the people misinterpret as computer-aided design. Sorry, the drafting. But computer-aided drafting is a part of computer-aided design. So CAD is a very broader term, and computer-aided drafting is the part of your CAD. Drafting means only drawing something with the help of by taking use of making use of computers. Okay, so CAD hardware basically includes computers, display terminal, keyboards, and other supporting or peripheral equipments. Okay, so this is what we call CAD. We have electronic input and output devices. Output devices like plotters, input devices as keyboard, then uh, hard copy units, etc., which is shown in the figure. So this is called as complete CAD hardware, which is used for the computer-aided design. So CAD software is divided into two parts. First is system software and second one is application software. So what is system software? It is basically used to perform or control the operation of the computer. So to run the computer or to perform the operations on the computer, you need uh, the some softwares. The softwares are called as your system softwares, like Windows. Windows is your system software. Linux, Ubuntu, all these are the system software, which is basically used for the uh, performance or to control the operation of the computer. Now, these are responsible for making the hardware component to work and interact with each other and the end user. So, end user is we, the people, the person who is working on that particular system. So, what is the function of the system software? It is facilitates the interaction between your computer hardware and uh, your system and the end user. Then application software. It is also known as application program. These are the customized or specialized program. Like in your system, the Windows is your system software, and various application software are like that. If we could consider the example of CAD, we are having AutoCAD, SolidWorks, ProE, ANSYS, Adams, LS Dyna, Hypermesh, etc., etc. All these are the application software. So application softwares are made for specific purpose. So for solving that purpose, for serving that purpose, we use the application software. Now, what are the advantages of application software? It increases the design productivity because you know that in previous days, earlier days, we used to have the drawing boards, the drafters, and the pencil, and then we used to sketch something. We used to draw the diagrams. We used to draw orthographic and isometric projections. So it used to consume a lot of time, so that is reduced and the design productivity has been increased. Shorter lead time, flexibility in design, the manipulation is easy as compared to the conventional process. Design analysis that we make, previously we used to make the analysis with the use of empirical relations, some derived relations, some governing relations were there, and by making use of those relations, that's empirical equation, we used to analyze the design. But nowadays we are having various application software. With the help of those softwares, we can analyze the design, and it has been improved a lot. Because of the assistance of computer, there are the less errors in design and the accuracy in design calculations. These are the obvious advantages of computers. The documentation, as drafting and documentation is very important part of the CAD or the complete design cycle. So documentation is also very easy, and it is convenient for the user, and it has been standardized when we while by taking help of the CAD. Easier creation and correction in engineering drawing. Obviously, uh, we it's difficult to correct the drawings when we talk about the conventional process, but it is quite easy with the help of CAD software. Visualization is also easy because we used to draw the isometric view from the orthographic views or vice versa. So that visualization with the help of the geometric modeling software is very improved, and it has been very easy to visualize the drawings. And the faster new product design. So we are taking help of computers and the various application related application software. So the design products will be uh, is has been improved. Now the benefits of CAD in manufacturing. So CAD is, although it is related to a design term, but we make use of the CAD in manufacturing also. So it is used for the tool and fixture design, then generation of numerical control part program, computer aided process planning, and the model generations generated can be used for rapid prototyping. Like this is the additive manufacturing is one of the newest technology in an industry. So we can generate the models on the computer, then we can convert it into .stl format. We can directly send it for the rapid prototyping or additive manufacturing process. So again, it will help, your CAD design will help in manufacturing. Then computer aided inspection. So quality control, quality checks with the help of computer is also useful with the help of computers. Then preparation of assembly list and bill of materials is easy. Group technology. So group technology is all all the concept of group technology you will be going to study in your unit number 5. So in that, the coding and classification of parts is done. So what is basically group technology? The parts having similar geometric or design features are grouped each other, grouped in a or it is gathered in a one single group, and then the some scientific procedures are carried out on those for processing it further. So group technology is also beneficial, got benefit with the help of CAD. Then robotics and material handling equipment planning can be done with the help of CAD, and assembly sequence planning. So yeah, whatever the 7 8 points mentioned over here, all these are related to manufacturing. But your CAD, computer aided design, or the use of computers and related application software will help all these features, help to improve all these features. Now, there are 4 fundamental reasons for implementing the CAD system. So there are few reasons why we use the why the industry implement the CAD system. So to increase the productivity of the designer. So we can, by using the CAD, the designer can visualize quickly the product, its components, sub assembly, and parts. It is obvious that you also work on some geometric modeling softwares, so it is very easy to visualize the products, the sub assemblies, the parts through which by which the assembly is made. So visualization is quite good. There is very reduced time required for the synthesis, analysis, and documentation of the design. So time is has been drastically reduced, and the design time and cost is also reduced. This is the first reason, fundamental reason why to implement the CAD, to increase the productivity of the designer. Now the second part is second fundamental reason is to improve the quality of the design. So design alterations can be quickly done without error. So anything that if we require in any alteration or any manipulation, if we require in the design, that can be done very quickly within very less duration of time, and that too without error. Then there is a I think this is very important, what we can say, the advantage or the fundamental reason why to implement the CAD is to improve the communication. So previously what happens, why there is what are the bridges or the gaps, why the CAD has not been implemented so efficiently, just because of the communication. So once the communication has been improved in between the various islands of the manufacturing and the design parts, uh, the entire process is also improved. So the communication provides better documentation for the design and fewer drawing errors with the greater legibility. So there is a communication between various islands of the design process, and there has been improved in the communication. So to create the database for the engineering, uh, it consists of product geometries and dimensions, bill of materials required, then what are the various processes, what are the various sequences of operation that is required for the manufacturing of product. So all this database has been created, or it is easy to create it, the database which is required for the engineering the product. So these are the few reasons to implement the CAD. Now there are applications of the CAD, few areas where we can use the CAD. So first area is design. So what are the applications? So assembly layout, new part design, standard part library, tolerance specification, interface and clearance specification, part relations in an assembly. So in design field, design area, these are the application. So analysis, second is analysis, interference checking, fit analysis, weight and balance, volume and area properties, structural kinematic analysis, tolerance stacking. So analysis we can do with the help of CAD. Documentation, whatever the features you have generated, that drawing can be generated, technical illustration will be there, bill of material, image rendering, all these things can be included in the documentation. Next is manufacturing, which is very important because CAD and CAM are the integrated with each other. So process planning, NC part program generation, verification, machine simulation, inspection of the programming, robot programming and verification, and factory layout. So all these manufacturing features or these applications can be served with the help of CAD. And the last one is the management. So review and release of the product, and there, if there are engineering changes are there, that can be incorporated. Then project control and monitoring, selection of standard parts and assemblies, and design standards. So these are the applications of the CAD, like your design, then your analysis, then your documentation, manufacturing and management. So all these aspects, in all these areas you will find the CAD. Now let us go for the design process in a CAD system. So these are called as elements of the CAD system. So conventional design process starts with the drawing boards, and these are documented with the help of your the sheets or the blueprints of the drawing. Now the conventional design process, which is known as Shingley's model, there are six basic steps are there. First is recognition of need, identification of the problem, synthesis, analysis and optimization, evaluation and presentation. All these are the six phases for the conventional design process. Now we going to use or going to see how the CAD incorporates into this. So there are four functional areas or stages in the CAD. So first is geometric modeling, design analysis and optimization, design review and evaluation, and documentation and drafting. So you must remember these four stages of the CAD design process. So previous was the conventional design process, and this is the CAD design process. So what is geometric modeling basically? So these are the four stages, and this is the traditional uh, design process. So computer aided design will help, or it supports the traditional design process in these aspects: synthesis, optimization and analysis, evaluation and presentation. So what is geometric modeling? So geometric modeling concerns with the computer compatible mathematical description of the geometry of an object. So whatever you are drawing with the help of on the geometric modeling software, that is called as your geometric uh, modeling. So what is mathematical description of the geometry? So it is the image of an object that can be displayed and manipulated on the computer terminal. Let us say you are drawing the triangle, so it is having some mathematical description. So what mathematical description it includes? It is having three vertices, and the three vertices are having three the coordinates. If it is a two-dimensional, there are x and y coordinate, and if it is three-dimensional, there are x, y, z coordinates. So those coordinates describe the mathematical description of the geometry, which is displayed on the screen. And if you want it to manipulate, as you might be aware about the various transformation like translation, scaling, rotation and mirror, so you can manipulate with the help of the computer terminals. This is one of the description. Then a modification of the geometry of an object can be done easily. Within a no time you can perform all these transformation, and with just a click of a command. And it can be stored in the computer memory. You can any time, if you want it, you can retrieve it back, and you can again manipulate it. So you can retrieve it back on the computer screen for review, analysis or for alteration. In geometric, there are three types of commands are used geometric modeling, like to generate the basic geometric entities, because this is very important to know as far as your few basics of CAD is concerned. So commands for generate basic geometric entities are points, lines, and circles. So if you go through any mm, uh, geometric modeling software, these are the basic entities you are ready-made for you. So that, like, create a point, create a line, create circle, create a rectangle, create a square, or create a polygon. All these commands are used. Then second type of commands are used are for the manipulation, like your transformation, like scaling, translation, rotation. So these are the second type of command. Okay. So and the models can be represented in the three ways, like wireframe, surface and solid modeling. So what is wireframe modeling? uh, because every software, every 3D modeling software consists of these kind of model. Wireframe model means the model is represented in the form of a mesh, uh, that is called as wireframe modeling. These are generally used for the analysis of the aerodynamic structures. Then surface modeling is when the length of an object is very large as compared to the thickness of the object. In that case, the surface modeling is used, like when you are preparing some sheets or you are preparing some panels of the car, then surface modeling is used. And then the solid modeling, when the thickness is comparatively good as compared to your length of the product, then solid modeling is used. So these are the three different ways the models can be represented. The second stage of the CAD design process is design, analysis, and optimization. So once the model is generated, the design it's sent for the engineering analysis. Now, in this engineering analysis, uh, we analyze for the model for the stresses, strains, deflections, and other parameters. Okay. So it can be used either by using the specific program or by the use of the general purpose software which are commercially available in the market. Now, if you know the sophisticated packages as ANSYS, POE, CATIA, which are available to perform the various to evaluate the performance of the various parameters, and that too with accuracy. So and if it is used with the help of it is used easily, such analysis can be made by the designer, or increasing willingly to truly analyze the design before it moves for the production. So it has to be when the product is, or the drawing is ready, it needs to be uh, evaluated for the analysis. So that is important step. Then design review and evaluation. So whatever the analysis what we have done, that has been reviewed and it has been evaluated on, and it is checked on by various checkpoints, and then it is sent for the documentation. So documentation and drafting means whatever the blueprints are there, whatever the mm, drawings are there, the soft copies are there, those working drawings are developed and then it is printed, and those working drawings are then sent to the shop floor for the further manufacturing. So you can have the different drafting features like automated draft, dimensioning, scaling, then various sectional view generation, enlargement of the minute parts, different views like orthographic, oblique, isometric, perspective views. So all these can be very easily available, and we can perform all this documentation very easily with the help of softwares. Okay, so there are four stages of CAD in the design process: geometric modeling, then engineering analysis and optimization, design review and evaluation, and documentation and drafting. Now coming forward, what is CAM, computer aided manufacturing? So what is aided manufacturing? It can be defined as the effective use of computers and computer technology in the planning, management and control of the manufacturing function. Okay, so all these words are very very important: planning, management and control of manufacturing function. Everything is controlled with the help of the computer technology. So computer assists all the phases of manufacturing of a product, like process and production planning, machining, scheduling, management, and quality control. So these are the few important islands in manufacturing. So all these islands are supported with the help of computer and computer technology and the associated application softwares like production planning, machining, scheduling, management, and quality control. So when we are taking use of a computer to assist the manufacturing processes, then it is called as computer aided manufacturing. Now it is the CAM has been divided into two parts, like manufacturing planning and manufacturing control. So planning and control are the two broad categories. So CAD CAM interface are having all these things are combined together to have a better product life cycle. So by interfacing the CAD CAM technology, it is possible to establish a direct link between product design and manufacturing engineering. So both in what happens in conventional processes in previous days or earlier days, all these departments like design and manufacturing, and then your quality control and your procurement and services, all these departments work separately as an autonomous body. So nowadays what happens, the concept of concurrent engineering, everything is working simultaneously in having hand to hand with each other, and it results in a better product design, and it results in a development of a better product. So that's why the interfacing or the combination of CAD CAM technology is very very important. The user can interact with computer through graphic terminal to accomplish all the design and manufacturing activities. So it's not like that the CAD only used for the design purpose. It also used for to control the or to accomplish the manufacturing activities also. For reference, you can refer if you have attended my lecture on computer integrated manufacturing, so that will made your ideas more clear what exactly the interfacing of CAD and CAM is there. So this diagram interface it gives you the idea about how it is interface. So everything is depends on the exchange of the database. So exchange of an information. So whatever the data generated in CAD, it has to be interchanged, or it has to be communicated to the CAM and for the further processing. Like you are having CAD is having four processes: geometric modeling, analysis, kinematics, and automated drafting. So, and this is the interactive terminal where user can input the data, analyze the data, review the data, draft that data, and it is stored in the database, which is then communicated for the on the manufacturing side, which can be generate the numerical control. Then it is used for robotic operation, process planning and control, and the factory management. So it gives rise to the an automated factory. Now let us take an example. Uh, uh, I have demonstrated you one software called MasterCam. In that software, I have first created a model by using the application software, that is MasterCam. Then I have performed the various machining operation onto that, like milling, then drilling, and then contouring and facing, all that stuff. And based on that operation, the application software had generated one NC program. So and that NC program is your database. Now I have I can directly transfer that NC program to the machine, numerical control machine or CNC, and that CNC will perform automatically, and the product will be coming out from the machine. So whatever this CAD is used for the generation of the data, scientific data, mathematical data, which is stored somewhere. Mostly nowadays it is stored in the cloud because the data is very large. So that database is then communicated, or that data is communicated to various aspects of CAM, for various aspects on the shop floor, various mm, machines on the shop floor, and then it is used for the various islands of the manufacturing. So that's why the CAD CAM interface is very, very important, and everything is revolves around this database. Now, what are the elements of CAD CAM interface? So, CAD CAM combination allows the transfer of information from the design stage into stage of planning for the manufacture of the product without the need to re-enter the data on the part geometry manually. So once you have generated the data on the CAD part, you need not to again re-enter the data on the CAM part. It can the exchange of information or the transfer of information can take automatically. So the database which is generated or developed during the CAD process, it is stored, and then it is processed further by the CAM into the necessary data and instruction for operating and controlling the production machinery, material handling equipment, on automated testing and inspection for the product quality. So modeling data, analysis data, review data, documentation, whatever the data is generated, which is here we can see the shared database, and that database then now can exchange for the process planning, part programming, tool design, material ordering, etc., etc. So every feature of manufacturing is covered in this, and that this data is traveling in the two direction. So what is the use of bidirectional data? If you need to manipulate the data, if you need to alter the data, want to some alteration in that data, that is also possible. Okay, and if some new product is there, you can easily make the changes into that data, you can easily alter that data, and that will give you an advantage or a cutting edge, that your product will come out in a better way and in faster manner. Now there is one difference between CAD CAM and SIM, computer integrated manufacturing. So the scope of CAD and CAM include design, manufacturing planning, and manufacturing control. Now, so far as we have considered or discussed that, the scope of the CAD CAM include the design, manufacturing planning, and manufacturing control. Okay, so the typical application of the CAD CAM includes programming of NC and CNC and industrial robots, design of dies and mold for the casting, dies for metalworking operation, design of tools, quality control and inspection, process planning and scheduling, and plant layout. So these are the typical applications of the CAD. Now, after understanding CAD, if we go for the SIM, so you can see that the SIM is the a broader term, uh, which includes your CAD and CAM. So computer integrated manufacturing include all the engineering functions of CAD and CAM along with the firm's business function that are related to the manufacturing. So CAD CAM is an integrated part of your computer integrated manufacturing. So all the engineering functions of CAD CAM that is included in the SIMS, and additionally SIM supports the industry's business function, which are related for the manufacturing. So SIM is equal to CAD CAM function plus business function. So this is a very common diagram. This is called a SIM wheel. So we are having first outer wheel is scope of scheme SIM. Then we have scope of CAD CAM. In CAD CAM, we are having design, manufacturing planning, and manufacturing control. And if we add business function, so it is included in under the scope of the scheme. Then we are having factory operation. So this is basically your physical operational unit factory. All these function design, planning, and manufacturing control are related functions to the factory operation. And the business function, now what is basically business function? Business functions are the functions which are used for the effective management and control of the entire firm. Like uh, if you are using the if you are manufacturing some product, so the location, if you are sitting in US and your factory is in Sakan, so you should be able to control all the business function from over there, and it is possible with the help of exchange of information. So whatever the functions, like what is your inventory at present, what are the materials you are requiring, what is the how much stock is available in that in your inventory, what is the current cost of that material, uh, then how your product is going to be launched, what are the payback period of your product, what are the what are the various variable and fixed costs that are being incurred for manufacturing that product. All these functions are included in your business function. So business functions are the functions which these are the decision which is influencing the decisions for that are used to make for the efficient operation of the factory. So SIM is a broader category. Then coming to the computer aided drafting. So in the start of the session, I told you some of the people misinterpret that CAD is your computer aided drafting, but it is not computer aided drafting. It is computer aided design. So computer aided drafting is very simple term. So the process of preparing drawing with the aid of computer is known as computer aided drafting or computer graphics. Just computer aided drafting is merely the drawing preparation that you are preparing with the help of your computer and the application software like your Pro-E, CATIA, Creo, etc. The computer graphics include the method of making plane and geometric drawing. So method of making plane means creating your sheet. So in your conventional drawing, your sheet is your plane. Plotting of points, drawing of lines, square, circle, etc. Then and the building up of some simple blocks from the computer graphic activities into two dimension. Then we can have pictorial views of a machine component as viewed from the different direction that can also obtain with the help of computer graphics. All these things you have studied in your computer aided machine drawing CAMD. Uh, so in present days, the availability of sophisticated computer hardware and computer programs have enabled solid modeling, which is a 3D representation of the product. You can directly prepare a 3D product. The entire computer graphic activities, then it is integrated with the help analysis, design, manufacturing, and manufacture management aspect into one system that is called as computer aided engineering. Then one more term is there, computer aided engineering. So what is computer aided engineering? It is analysis, design, manufacturing, and management aspect. So it is called as computer aided engineering. So the functions performed, major functions performed by the computer-aided drafting system, basically to set up the basic setup for the drawing, then draw the objects, change the object properties, translate the object, scaling the object, clipping the object to fit the image on the screen, creating the symbol libraries for frequently used object, text insertion, dimensioning. So if you look carefully, all these points mentioned in the slide, so all that stuff you perform in your conventional engineering drawing. You set up the drawing, you set up your sheet, you draw the object, you change the object properties like mm, you can change it from orthographic to isometric or isometric to orthographic. Then you can change the position of the object, you change the shape of the size of the object. You use to clip the object, you take a scale and then you try to fit it on the sheet. Then you use the various symbols like tolerances and geometric dimensioning symbols on the sheet, or the various sectioning symbols. You use different types of lines. uh, that is all included in the symbol libraries. Then you insert the text like front view, top view, left hand side view, right hand side view. Then you are having your nameplate, who is prepared this, what is the title of the drawing, what is the bill of the material, what are the parts over there. So all these are included in the text insertion. And then you have dimensioning, the length, the various dimensioning systems you use for dimensioning the particular drawing. So these are the major functions performed by the computer aided drafting system. Now, what are the advantages of computer-aided drafting? It is fast and convenient. Your drawing can be stored in the database. It is in the soft copy. You can easily retrieve it for the review and analysis and manipulation. Changes in the drawing can be done easily and quickly. Then you are having neat and clean drawing of good quality that can be prepared, and accuracy is also maintained. So these are the advantages of computer-aided drafting. Now, the features of the CAD system, modeling and drafting. Whatever the CAD system you are using, so these are the common features that are used. Modeling and drafting. A majority of the system provide 2D and 3D modeling capability, and some low cost. It is for 2D drafting only, like your AutoCAD. But AutoCAD also facilitates some kind of 3D modeling. Then ease of use. Users find the CAD system for the easy to learn and use. Then there is flexibility. So CAD system provide greater flexibility when configuring with the available hardware. Hundred of computers, display devices, expansion boards, input and output devices are compatible and configurable with the popular software. Like in your CAD lab, you are having 50 computers, so display devices, all these are compatible and configurable with the help of popular software. So you are having ANSYS you can configure on various operating system, various system configuration. So that are compatible, and that provides a flexibility. Then you are having modularity. Standard input and output devices are attached to the standard connector, thereby making the system in modular in nature. So input and output devices, so it's a standard connectors. So what is connector? The USB ports, or nowadays you are having C type connectors are there for your laptop. So these are the some standard input and output devices. So wherever you go on the around the globe, you will find there are standard connectors, and that will provide you the modularity. Then there is low maintenance cost. So you are having very little maintenance needed for the to keep your system functional. Just you have to install the upgrades for the system, and the software packages for the modeling. There's a one-time cost over there you have to incur. Now, the CAD packages available for the modeling are AutoCAD, ProE, Ideas, Unigraphics, CATIA. Then you are having SolidWorks, Solid Edge, etc. These are the characteristics of the CAD package: simplicity, consistency, completeness, robustness, performance, and economy. Simplicity means it must be user friendly. Consistency means it should have repeated the accurate results. So it should not have, if you are drawing a 2 centimeter line, so every time it should be a 2 centimeter, not more than that. There should not be error. And then the completeness, whatever the task that is expected by the end user from the CAD software or the CAD package, that should be fulfilled. That is what we called as completeness. Then it should be a robust, the performance must be good, and it should be obviously economical. Then manufacturing planning functions or planning applications, it include computer-aided process planning, computer-assisted NC part programming, computerized machinability data system, development of work standard, cost estimation, production and inventory planning, and computer-aided line balancing. All these are the manufacturing planning operations. We are not going into detail of this. We are just going to discuss the computer-aided process planning and computer-assisted NC part programming in unit number 4 and 5. So this is the first phase of your presentation, introduction of the CAD. Now the design process is there. I have already explained this. There is now the second part of the unit is, after introduction, is your transformation. Now, what is the definition of transformation? Second. Yeah. So, what is transformation? So, object transformation is the mathematical operation of the manipulation. Okay. So, when the entities of the CAD model are manipulated by moving them around or by taking one or more copies of different location and orientation, then the image of the coordinate system to be stationary and the object is to be moved. Okay, so there are two types of transformation. First type is your object transformation, in which you are changing your coordinates of the object or mathematical description of an object by keeping the coordinate system same. And the second transformation is coordinate system transformation, where your image is stationary, your geometry or entity that you have drawn is stationary, and the coordinate system is going to move. So you remember, there are two transformation: object transformation and coordinate system transformation. So the main task of the transformation is to define the new object. New object means the transformed object. Then the transformed object can be defined with the help of P star or P dash, which is the new object coordinate matrix, which is equal to the original coordinates of the matrix, and T is your transformation matrix. Okay, so this is very popular thing that is you need to remember. Now, the intention behind studying the transformation is you must be able to understand what exactly happens inside the computer memory, or what are your application software is going to perform while you play with your object. Like if you have drawn one triangle and you need to scale that triangle, you have to make it size double than what it's presently it is. So you just click it on, you can give the scale the triangle, you use some commands, and your size of that triangle is going to change. But being engineer, being subject expert of CAD, you must be able to understand what exactly application software perform, how the mathematical manipulations has been carried out. Okay, so that is the task of learning the transformation. Now whatever the coordinate data is present over there, all that data is stored in the form of matrices, and the core or the core of this transformation is matrix multiplication. So this is very very important that you must know the matrix multiplication. 2 by 2, 3 by 3 matrix, 4 by 4 matrix. So up to 3 by 3 matrix multiplication you can perform on your calculator. For 4 by 4 you have to go for the manual multiplication. So the aim of this lecture is to give you what is happening within the CAD system. So what is happening within the CAD system, as I told you, while performing the transformation, and by understanding how something work allows us to use it more efficiently. Now, if you know how the things are performing or how the things are carried out, you can use it very efficiently. Apart from using it blindly, now you know how to use the commands on the 3D modeling software or 2D modeling software, but if you know how they are executed by the software itself, then you can use it more effectively and efficiently. Okay, so these are the examples. This is one line which is represented by 2 points P1, P2. Now P1 is having coordinates x1, y1, and P2 is having coordinates x2, y2. So it can be represent, this point can be represented with the help of the matrix, and the line is also represented with the help of this matrix. So we are basically the line, we are storing the coordinates or storing the points in the software in this matrix form. For the triangle, we are storing it x1, y1, x2, y2, and x3, y3 as the uh, coordinates of the triangle. Now, there is one concept called as homogeneous coordinate. Now, sir might have told you what is the use of homogeneous coordinate. So, generally in 2D space, we represent the points like x1, y1, x2, y2, and x3, y3. Okay. Then why we are using some more coordinates? So why we are using it? If you go on through the transformation, the multiple transformation or the concatenated or composite transformation, there is multiplication of the matrices. Okay, multiplication of the matrices. Like you are going for scaling and rotation for the single transformation, then there is a multiplication of matrices. But if you include translation, that is changing the position of an object, then there will be addition. So it will create the confusion, or it will create difficulty and complication in matrix calculation, the final answer calculation. So to avoid that difficulty, we use the homogeneous coordinates. We use one more coordinate. We'll use one more row having coordinates 1 1 1. So that because of these things, because of the homogeneous coordinates, it will be easy for you people to carry out the all the transformation just by multiplying the matrices. Every transformation is can be obtained, specifically composite or concatenated transformation, with the help of matrix multiplication. Okay, so the transformations can be used for the changing in geometric object, change in location, translation, change in shape, uh, then change in size. Change in shape you can use with the help of shear, but that is not in our syllabus. Change in size, your scaling, rotation, copy means mirroring, generate a surface from a line, generate a solid from the surface, and animate the object. Generate a surface from the line means draw a line and extrude it with the help of very fine thickness or negligible thickness, then we can generate a surface. If you are having a solid, just draw a circle, extrude it, give some major dimension, and you find a cylinder. So that is a generation of the solid from the surface. So these are the transformations, modeling transformation or object transformation. And second is viewing transformation or coordinate system transformation. I already told you, object transformation is you can alter the coordinate values of an object by keeping your uh, mm, coordinate system same. And visual transformation, in which your coordinates of an object will remain unchanged, but your coordinate system definition is going to change. So this is all for today's lecture, I think. Since time is running up, uh, I'll start with once again tomorrow with the transformations, and we'll solve few problems on transformation. Don't worry, I'll be revising everything. We'll be started with a fresh unit, and from the scratch, and I'll be covering every aspect. Okay, so that's all from my side. You just put your attendance on chat box, and then you can leave the session. Put your roll number in the chat box and leave the session.
Sir, when will be the result being shown?
You check by today evening.
सर रिजल्ट दिखा रहा है.
Sir,
दिखा रहा है?
हाँ.
sir, I checked it from 2 a.m. at night till now. It is not showing.
प्रज्वल
I
अभी दिखा रहा है.
Yesterday only I talked with Loda sir. He was in university last day, yesterday, and he said by today evening everything will be cleared.
Okay, sir.
So mostly it is showing now.
Yeah, yeah. I hope it is showing.
It should मेरा नहीं दिख रहा है.
प्रज्वल दिखा रहा है अभी.
हाँ ठीक है. मैं तेरे को नंबर फॉरवर्ड कर
अभी
रहा
दिखा.
हूँ.